Hello, welcome to Pre-Algebra with Miss Betsy. Today we are going to be continuing our study of statistics and probability by talking about how we deal with mutually exclusive events. And mutually exclusive is a term that you may or may not be familiar with, but it's used quite commonly. Things are mutually exclusive if you cannot do them at the same time. For example, if you have a pickup truck and car at home, it's not possible for you as the driver to be driving both the car and the truck at the same time. So that's what we're talking about when we speak about events that are mutually exclusive when we're determining what the likelihood is of something occurring. So if you're using the same text that I am on page 465, section 13.7 in this text. It's Pre-Algebra for Christian Schools. It's published by the Bob Jones University Press. It's the first edition. You don't have to have that same edition, the same publisher even. This is just talking about mutually exclusive events at a pre-algebra level. So I have a lame riddle for you today. More about piggies, and this is the second time I've recorded this video. I hope that this is the correct riddle to read to you. What do piggies practice in karate class? Well, in karate class, those piggies are always going to be practicing their pork chops. Rather than karate chops, they have pork chops. So, what I have on the board before you is a spinner, and I only have 3 colors of markers today. I have black, I have this brown, and this lighter color here, which I hope shows up on the video, is a purple. So I have 3 different colors of numbers on this spinner that has a total of 8 possible entries. If I were to spin it, I could either end up with black number or brown number or purple number. So what would be the possibility or the likelihood, we would say the probability that when I spin this, that I'm going to have either a brown or a purple number? Well, remember that our probability of an event occurring is a rational expression. It's a ratio where the numerator is the total number possible of positive outcomes, meaning we get what we want. If we want either to have a brown number or a purple number, how many choices do I have? 1, 2, 3, 4, 5. If I get a 1, a 2, or an 8, that's a black number, and that's not what I want. So that's not the positive outcome. And how many possible choices are there that my spinner can land on? Well, obviously there are 8 choices. So then the probability of when I spin that wheel of getting either a brown number or a purple number is 5/8. It's 5 chances out of 8. And this is what we call, we're going to deal with mutually exclusive events. And they are going to be separated with or. It can be either, in this case, a brown or a purple number. And the way that you find the probability of mutually exclusive events is you combine the probability of each of those events individually. And we figured that out just by counting the numbers. But let's use their formula here. Let's say that A is the probability of getting a number that is brown. What's the probability of that? 1, 2, 3. The probability of a brown number is 3 out of 8. Because the total number of choices, again on this wheel, we have 8 possible outcomes. And let's say that the probability of B occurring, that's the purple numbers. There are 2 choices for the purples. So the probability of purple is 2 out of 8. And when we combine those together, you see that the probability of either a brown or a purple number, being the point at which that wheel stops, is 5/8. All right, so it's very, very straightforward here. So let's go ahead and look at another example from the book. And I'm going to use markers to indicate what color these cards are supposed to be, because we're going to have number cards that we're using. And we have white ones, and we have blue ones, and we have red ones. So we're going to say that we have 2 white, 4 white, 6 white, and 8 white. Okay, the W means that this is on a white card. Now we're going to have 1, 3, 5, 7. We're going to change the colors to what I have. 1 purple, 3 purple, 5 purple, or 7 purple. And I'm not sure where I got that 5. That's supposed to be a P. 7 purple. And then we're going to have our black numbers be multiples of 10, beginning with 10. So we have 10 black, 20 black, 30 black, and 40 black. And drawing on this example that we have here in the book, it says, if one of the number squares is drawn at random, find each of the following probabilities. Would be the probability of white or purple. Okay? How do we find the probability of mutually exclusive events? Well, we see what's the probability of white and what is the probability of purple. How many possible choices, how many possible outcomes are there here? There are 12, 3 groups of 4. So the possible positive outcomes that are white, how many are there? 1, 2, 3, 4. So we have 4 white ones. We also have 4 purple ones. So we have 4/12 plus 4/12. Remember that our numerator is the number of positive outcomes, or the number of possible opportunities for us to draw the card that we want to get. We want to get one that's white. We have 12 there. 4 of those are going to be white. Now we want to know how many purple. We have 4 purple out of 12 possible choices. 4 of those could be purple. Now we have to combine these. We have the same denominator, so we have 8/12. But probability is always going to be indicated in lowest terms, so you need to reduce that fraction to lowest terms. So the probability of drawing a card that is either white or purple is going to be 2/3. Okay? Well, now the next example that we have says, what is the probability of a multiple of 5 or white? Okay, the probability of a multiple of 5 or white. First we're going to pick the multiple. What's the probability of the multiple of 5? And I'm just going to shorthand it here. Multiple of 5 plus the probability of a white. We already know that the probability of getting a white card is 4 out of 12 because we just did that. But what about the probability of getting a multiple of 5? Well, we have 5, 10, 20, 30, and 40, all of which are multiples of 5, aren't they? But they're 2 different colors. Does it matter? Does this here address color at all? No, it doesn't say it has to be purple. It doesn't have to say it has to be black. It says nothing whatsoever about the color. It simply says it has to be a multiple of 5. So the probability of getting a multiple of 5 is, there are 5 choices. 5 out of 12 choices plus 4 out of 12 choices. For your white card, you have 9/12, which you have to reduce to lowest terms, so your probability of getting a card that you're satisfied with, meaning the card that is either a multiple of 5 or a white card, you have a probability of 3 out of 4. Pretty straightforward. What about if we wanted to say what's the probability of getting a purple card and a number that was greater than 20? Or a number that was greater than 20. A probability of a purple or a number that is greater than 20. How many purple cards are there? 1, 2, 3, 4. Probability of purple is 4 out of 12. What's the probability of a number that's greater than 20? Well, there's only 2 numbers there, isn't it? 30 and 40, so 2/12. You have a probability of 6 out of 12, which reduces to a 1 in 2 chance, or 1 in 2 likelihood that you will get the card that you're drawing on the first draw. That's all that is involved in mutually exclusive events. So go ahead and do your best to work through those. If you come across something that looks a little bit different to you, you get stuck, don't be afraid to send me a text, and I'll see you in class on Friday.